Bismillahirrahmanirrahim. Assalamu alaikum. My name is Fajar, and this is my certificate for 5th course, Introduction to Relational Databases in SQL. And it was awarded to me on 19 March 2022. Now I will discuss what I have learned in this course. Introduction to Relational Database in SQL, course number 5. First of all, we will discuss chapter 1, which is Introduction to Relational Databases. A relational database is a real-life entities become tables, reduced redundancy, data integrity by relationships. For example, professors, universities, companies. For example, only one entry in companies for the bank Credit Suisse. For example, a professor table can work at multiple universities and companies. A company can employ multiple professors. Throughout this course, I worked with data used for my investigation, created a relational database from scratch, learned 3 concepts which are constraints, keys, and referential integrity. Now we will discuss chapter 2, which is better data quality with constraints. We will discuss what are integrity constraints, attribute constraints, for example, data types and columns, which are discussed in chapter 2, key constraints, for example, primary keys, which are discussed in chapter 3, third are referential integrity constraints enforced through foreign keys, which are discussed in chapter 4. Now the question arises why we use constraints. Constraints give the data structure, constraints help with the consistency and thus data quality. Data quality is a business advantage and data science prerequisite. Enforcing is difficult, but PostgreSQL helps. Now we will discuss data types as attribute constraints. Bigint is used for signed 8-byte integer. Bit is used for fixed length bit string. Bit varying is used for variable length bit string. Boolean is used for logical boolean, true or false. Box is used for rectangular box on a plane. Byte is used for binary data. Character is used for fixed length character string. Character varying is used for variable length character string. And CIDR is used for IPv4 or IPv6 network address. This data has been collected from the PostgreSQL documentation. Now we will discuss chapter 3, keys and superkeys. Now the question arises, what is a key? A key is an attribute that identifies a record uniquely. As long as attributes can be removed, they are known as superkey. If no more attributes can be removed, they are known as minimal superkey or key. Now we will discuss primary keys. One primary key per database table chosen from candidate keys. It uniquely identifies records, for example, for referencing in other tables. It is unique and not null constants both apply. Primary keys are time invariant, which means that choose columns wisely. Now we will discuss surrogate keys. A surrogate key in SQL Server is a unique identifier for each row in the table. It is just a key. Using this key, we can identify a unique row. There is no business meaning for surrogate keys. Primary keys should be built from as few columns as possible. Primary keys should never change over time. Now we will discuss the last chapter 4 of this course, which is model 1 ratio and relationships with foreign keys. Implementing relationships with foreign keys. A foreign key fk points to the primary key pk of another table. Domain of foreign key must be equal to domain of primary key. Each value of foreign key must exist in a primary key of the other table. Foreign key constraint or in referential integrity. Foreign keys are not actual keys. Now the question arises how to implement NM relationships. For this, we have to create a table, add foreign keys for every connected table, add additional attributes. No primary key should be included. Possible primary key should be professor underscore ID, organization underscore ID, and function, for example. By using these steps, we can implement NM relationships. Thank you. This was all from my side. I hope that you have understood this course well.